Actually, I'm in here.
Okay.
So I studied mathematical physics, quantum mechanics, and classical mechanics.
Uh, can I request one thing that can you please join in another device? Like your voice is not that much clear. I can't properly hear you. So is it possible to join with another device so I can understand your voice clearly? Like
Yes, yes.
in that last class, your voice was very clear. So that's why I'm asking that can you please join in another device or I don't know from where you join in the last class. So it will be good. Like right now, your voice is like very much frustrating and all this. So
Okay, so now it is clear. Hello.
hello, hello.
So now, hello.
Yeah, yeah, it's fine, it's fine. Okay, just let's go to
Now
the.
it's clear. Actually, it's some. I have a headphone, so I think I will work it. I just enrolled the code
See,
in.
the same problem is there. I can't hear you properly. I don't know why.
Okay.
Uh,
So now it's clear. What is it now?
hello.
Uh, my voice is clear.
No, still not that much here.
No. Wait. Wait, ma'am. Wait, ma'am. Now it's clear, ma'am.
Yeah. Hello.
Okay, ma'am. Yes, I'm hearing you.
Yeah, it's fine. It's fine.
Voice is clear.
I think it's fine before that. Okay, so in the last class, what I did basically, as you said that you want to know some quark level, quark model questions, right? So here I will just listed a little bit because I thought that like I have found it so many questions in quark model, but I found that most of the questions, like let's say 90% questions is basically based on the reactions, like if any reaction is there, what is the missing particle, or one reaction is there, is it electromagnetic or is it strong or is it weak interaction. That type of question is 90%. And other question is also there, some relativistic question is also there, but I thought that like 70 to 80 or 90% questions are basically based on that which type of nuclear reaction it is, which type of quark is the missing particle in that reaction, something like that. So for that reason, I thought that I should make a table so that you can understand clearly that what is going in the nuclear reaction, right? So that's why. Can you see the screen right now? Hello. Yes. Hello. Yeah. Can you see the screen?
Ma'am? Yes, sir.
Yes. Okay. So here in that list, what I did, like in that list, you can see some quantum charges in the left column, and in the rest of the column, I was just mentioning that which interaction, like which quantum charge will be conserved in which interaction. So here you can see that the strangeness quantum number is conserved under strong interaction. Like under strong interaction, strangeness number should be conserved. And but for electromagnetic as well as weak, it may or may not conserve, and for weak, it obviously not conserve. And also for I means the isospin. Isospin should be conserved in strong interaction, but isospin should not be conserved in electromagnetic as well as weak interaction. And for I3 case, like strong and EM should be conserved here, and for weak interaction, I3 cannot be conserved. And then P, C, T. P means is the parity, C means charge conjugation, and T is time reversal, and CP CPT. So you can see that here, there was a typo in that last class also I was mentioning that in the CPT, for that CPT, weak interaction is also concept here. Like for CPT case, like for all the interactions, CPT should be concept. So that type of thing is there. But like for our question and answer session, we have to focus basically these three: S, I3. You can see here the difference. Like if these three all are conjunct, then we can obviously say that it is a strong interaction, right? Because in these three cases, strong interaction, in that strong interaction, these three should be conjunct. But if let's say S is not conjunct in our nuclear reaction, then it may be EM or may be weak. Fine. Now, let's say, so we can't say that which type of interaction it is. It is sure that it is not a strong interaction, as a strong strength is not concept in our interaction, but we are not confirmed that it is EM or weak. So that what we can do, we can just say it is a I thing. For I also EM and weak is not concept here, but if I check I3, and if I3 is conjunct, then we can obviously say that this is a EM interaction because strong interaction already gone. So EM interaction will be there. But if I3 is not conjunct, then we can obviously say that it is a weak interaction. Do you got my point? Like I will give you some example on that so that you can easily understand that which type of interaction it is. Just only by checking these three, we can say that this type, what type of interaction it is. Is it strong? Is it electromagnetic? Or is it weak interaction? Okay. So
Okay, ma'am.
yeah, so it's a very simple thing. Like I thought that it's a very it will be so complicated for you, but when I was just learning a little more, I thought that it's a very simple to understand that which type of interaction for a nuclear reaction will be. And one more thing is there, like baryon number, electron number, electric charge. These things should be conserved in all nuclear reactions, because as we all know that electric charge should be conserved, right? Not only electric charge, baryon number as well as electron number should be conserved in all nuclear reactions. And we have to keep in mind, in our mind we have to keep that B, L and Q in all reactions it should be conserved. So this is a noteworthy thing. Okay, so then I thought that I should list some of the important particles. Basically what you should do in every nuclear reaction questions, you have to remember at least some of the particles Stranger's number as well as JP number and I number. Like here I was just mentioning some of the particle. You can see that here some of the particle contents are there. So in that particle contents, basically what I was mentioning the I value, and charge is, you can know by that notation that if plus is there then charge is +1. It's very simple. And S number. So I and S number is very important for some of the particles. So you have to remember these particles S value as well as I value. So that's why, like for difference on our questions, I was just mentioning as a list here. Some of the particles I have mentioned here, and with that I have just mentioned some I values of each and every particle as well as their charges and their strangeness number. So this type of things are
And
there.
ma'am, P stand for parity.
Yeah, P stands for parity, but in our most of the nuclear reaction questions, we don't have to bother about P. I will show you, okay? But I have to think what is the value of I, what is the value of S, and what is the value of I3 for each and every particle. Like, see, here more than 100 particle is there in elementary particle physics. So if I have to remember all the particles S and I, then my head will burn. So it's not like that. I have to remember some of the important particles S as well as I, so that I can answer most of the questions in particle physics. Okay. So this
Okay, ma'am.
yeah, this list is like obviously for I, JP, charge and S. So we will use these things in our next questions, so that's why I was just mentioning here this type of particles. And in that next list what I was mentioning, I will just mention, okay. So here I was mentioning about some leptons. The lepton, 6 leptons as well as their I, J, P, B, charge and S. You can see here that all the leptons has 0 S because they are not strange particles. So that's why this dash is there. Dash is basically nothing but that the strangeness number is not applicable for leptons. But still I was just mentioning these particles here. Now I was just given a more example of quark constituents. Like for each and every particles, what will be the quark contents for K plus, what will be the quark content for K0, K minus and something. I was just mentioning some of these. I did not mention all of the particles quark constituents, but I was mentioning some of them. As well as I was just mentioning some of the baryons like P, A, sigma, cascade minus, sigma 0, lambda 0, something. Basically I was mentioning these type of particles here because these are very important for our nuclear reaction any nuclear reaction questions. So that's why I was mentioning here. Now I can tell something more about first question. I was already told this question in the previous class, but as you people were absent, so I'm just little bit recap these things. Let's say the question is like identify the particles by their baryon number, strangeness number and quark content. Okay. So what was the question? There are two questions basically. One is K minus plus P goes to pi 0 plus x 0. I will talk about first question and you have to solve the second question. Fine. Second question means K minus plus P goes to K plus plus y minus. So what is the question? The question is I have to find what is x0 and what is y minus, and also I have to find the baryon number for x0, strangeness number for x0 and quark content for x0 as well as y0. So let's come to the first question. So first question is this one. So here like baryon number, that means B will be there. So for K, baryon number is what? For K is not a baryon. So that means K baryon number will be 0. P will be 1. K0 is also 0 and x0 should be 1. So that we can have delta B equals to 0. So that means baryon number for x0 should be 1. Fine. Then come to the strangeness number. So I have to go that what is the value of K strangeness number for K minus. I can see here the K minus strangeness number. See here K minus, the strangeness number is minus 1 because this is the strangeness number list column. So K minus has strangeness number minus 1. So come again to that one. So here minus 1. P is not a strange particle, so that means its strangeness number is 0. Pi 0 is also not a strange particle, that means it has a is 0. And x0 will have, it should be minus 1, so that delta is will be 0. It's a very simple thing. Okay. And now coming to the quark content. So for K minus the quark content was what? It's written here. For K minus quark content is S U bar. So S U bar. For P what it is? U U D. For pi 0 what it is? Pi 0 is U U bar plus D D bar plus S S bar. Let's say I am taking only U U bar. You can take only U U bar or D D bar or S S bar in your convenience. And here x0 will be some quark content. So what will be the quark content for x0? Let's check one thing. See here left hand side the total quark content is like S U bar U U D. This is the left side quark content as a whole. So if I write here U U bar can give one value, then S U D is the final. Like I'm just simplifying this. It is not exactly what is going here, but I am just simplifying that what will be the right side quark content. So U U bar in the right side it is 1. So that means the quark content for x0 will be SUD. So quark content for x0 will be SUD. This is the answer. Got my point? Like how I can find the quark content of x0 only for calculating the left hand side. Yeah, only for from calculating left
Please
hand side.
say it about SUD. If you could.
Yeah, sorry.
Yeah. U value. How to find the how to solve the U value and SUD. How we get again? Please explain again. In the
Okay.
in the slide 8 only. Only slide 8.
Only slide it. Okay, okay. So what content I have to find for x0, right? So here, just a minute. Here the interaction is like that. Interaction says that k minus plus p goes to pi 0 plus x0. So we have to calculate. At first the what is the quark content for pi k minus. We should know that. Okay. So the quark content for k minus is u bar. Quark content for p is u d. Quark content for pi 0 is u bar. Now I have to find that what is the value of x0 quark content. This is the question. Okay. So what will be the value quark content of x? For that what I have just written here all the quark content in the left hand side. This is as a whole the left hand side quark content, and in the right hand side quark content what it is u bar and let's say x cube. Fine. Then u bar is there, it will give 1. Then as a whole what is left is sud in left hand side, and obviously quark content should be conserved in right hand side also. So u bar is already there, so for xq I can say sud is the quark content.
Clear, ma'am.
Fine.
Nice.
Fine.
Yes, ma'am.
Okay.
Got it. Yes.
Okay, so just to do the second question similarly, that k minus plus p goes to k plus plus y0, y minus. So that you can
Okay,
have a
ma'am.
feel.
I can do.
Uh, can you do right now? Like I can give you only 2 minutes. Can you do right now?
Now, okay. But I need to table. I need
Yes,
table.
yes, yes, sure. Sure, I'm giving you the table, but you have to remember that it is right now I can give you, but you have to remember these numbers. Okay. So I am giving you at first the question. Just write down the question here. K minus plus p goes to k plus plus y minus.
Okay.
Okay. Have you written?
Yes.
Okay. Now come here. You have to find b value, h value, and q value for y minus. I'm giving you 2 minutes. So right now 17.
Okay.
And also I think you need the quark content. I will give the quark content also.
Okay, ma'am. Delta B is equal to 1.
Like y value, like b of y minus. What will be the value? B of y minus y minus. The variant number for y minus is what? Baryon number of unknown. It's 1. Okay, fine. Right. Correct. Then S.
and and
Strength is zero.
Strength is 0.
Yes, man.
Is it? K minus was there. So K minus means minus 1
-1. Okay, okay.
plus 0
And
because
the
proton has no strangeness number.
yes,
Then K plus is there.
and the K plus
Then what will be this value?
+1. Uh, +1. K plus is +1, but
Left hand side the S value is minus 1. So we have to say that
yes,
right
yes, ma'am.
in right hand side we have to have S value as a minus
Plus
1. So what will be the value here so that I can get here minus 1? See, if minus 2 is there, then minus 2 plus 1, it will get minus 1.
Yes, actually -2 will be the strangeness number, ma'am.
Yeah, so strangeness should be minus 2 for y minus.
Yes, yes.
So,
For the yes, actually, I'm thinking how -2 is going on. That time, because I actually I get the point. No -2.
but are you confused about minus 2 number? Like how minus 2 can come?
Minus. Yes, yes, yes.
See, in that quark content, if you can see, for quark S is the strange quark, right? So for quark S, the strangeness is minus 1. So if in any particle, the quark combination is like SS and something more, so that means it will give minus 2.
Yes, I got the -2.
Okay, now come to the quark
Just
content.
now.
Quark content. So tell me what will be the quark
Uh,
content.
okay. SU bar UT. Yes. And the one UT. SUD, ma'am. Quark structure.
SUD. How do you find that SUD? Okay.
Actually, the left hand side SU bar UUD,
Okay, just
and
a
the right
minute.
hand side we get.
Just a minute. This is the question, right?
Yes.
So what content for K minus was what?
SU bar.
SU bar. P is UUD. A K,
UUD. Yes.
K plus
SS K plus US bar.
US bar. And then I don't know this one. Okay. So let's take a left hand side. Left hand side means this one.
SUD. Get the point. SUD.
So U bar is there, so that means SUD is there. Okay. So right hand side. Right hand side means S U S bar and let's say some X, which will give us SUD. So just see here. Here one S bar is there, but in that side here one S is there. So in X it should be like something SS, so that this S bar and S will cancel and one remaining S will be there, which will give this U, this S. Okay, and
Yes, ma'am.
U is also there, U is there, so one D is missing, so that means D. So if I write U S bar S S D, then S S bar will give us 1 and U S D is remaining, which will be this one.
Okay, okay, ma'am. Actually, again mistake.
Do you got the point? Like here S bar is there,
I
but in the
Yes, yes, ma'am.
right hand side S is there, so we have to find S in that X. So what we should do, S bar is there, we have to cancel this S bar. So S bar can cancel only with S. So if I write one S again, then S bar will cancel. Then we have to put another S to have this S. So this is, and U is also there, so that D is there. So D S S will be the quark content.
Yes, yes, ma'am. Actually, uh, okay.
And
So
okay, so
go ahead.
just check is it correct or not. Whatever you have find that S for y minus was minus 2, right? So the quark content
Yes.
for y minus is what? DSS. So you can see that D will be 0, like for D S is 0, strangeness is 0. For S, strangeness is minus 1. For this S, strangeness is minus 1. As a whole, the strangeness is minus 2, which is the same as this one.
Yes.
Okay. Then it is correct. Like you can cross check again that whatever you have said, it is correct or not. Okay. So this first question has done. So here in that second question, I have to mention 6 equations, but I think I can only talk about 2 or 3 questions, and the rest of the thing you can do. Okay, it's a very simple thing. Not that much simple, but simple. So the question is what? The question is what quantum numbers, if any, are violated in the following reactions? Are the interactions strong, weak, electromagnetic, or none of the above? So we have to think, we have to at first calculate that. Let's say I am talking about this equation. So we have to calculate that this equation is valid or not. This is the first question. If it is valid, then I have to think that what type of interaction it is. It is weak, it is strong, or it is electromagnetic. But if this interaction is not allowed, then nothing is there that it is which type of interaction. So I have to first think that is it allowed or not. Is it a nuclear reaction allowed or not? So I have to find this one at first, and after that, if it is allowed, then I have to find what type of nature is there. So these two questions there. So I am talking about at first omega minus. Okay, so I think you have got the point that is it uh, allowed or not. I have to search, and after that, if it is allowed, what type of nature is there. So at first I am talking about first question. So first question is omega minus goes to pi plus and cascade 0. Now, as I already mentioned in that first slide, I think you have seen that in that first slide I was mentioning that in all nuclear reactions B, L and Q should be conjugate. So what I should do here, at first I have to calculate B, L and Q value for this nuclear reaction. So at first I am calculating B. B for omega minus is 1 because this is a variable, and pi 0, 0. Sigma cascade 0 is 1. So delta B equals to 0. Then B is conjugate here. Now coming to the L part. Omega minus is not a lepton, pi minus is not a lepton and cascade minus is not a lepton. So that means delta L equals to 0. Then coming to the Q value. Q means electric charge. Here omega minus has electric charge minus 1, pi minus has 0, cascade 0 is 0. That means delta Q is 0. So as these three are all conjugate, then I can say that yes, omega minus goes to pi minus 2, pi minus and cascade 0, it is allowed. Okay, so at first I just confirmed that this nuclear reaction is allowed. Now what should I do? I have to find that which type of interaction it is. Is it electromagnetic, is it weak or is it strong? So these three will give us the confirmation that this nuclear reaction is allowed. Now coming to the next part, that is what type of interaction it is. So for that, what I said before, that we have to check at first S, then I and I3. Only these three can give us the confirmation of what type of interaction it is. So let's check. So again I am writing here pi minus plus cascade 0. So the S value for omega minus, S value is minus 3. I will show you if it is problematic for you. And pi minus has S0 and cascade 0 is minus 2. I will show you. Okay. Just a minute. Omega minus and cascade 0. Right? Yes, here. See, omega minus has S value minus 3 and cascade 0 has S value minus 2. And pi 0 has pi minus has S value 0. Fine. So I am just talking about only S here. So here in the left hand side you can see that S is minus 3 and in the right hand side S is minus 2. So that means delta is not equals to 0. That means strange base number is not conjugate here. So in our first slide I mentioned that yes, here S should be conjugate in strong interaction, but S may or may not be conjugate in EM or weak interaction. So by only saying that S calculation, we can say that it is not a strong interaction, because in that reaction delta S is not 0. So that means it is confirmed that that interaction is not a strong interaction. It may be EM or it may be weak. Fine. Now come to the I and I3 calculation. If in I3 calculation I will find that delta I3 equals to 0, that means we can confirmly say that it is a EM interaction. If delta I3 is not equal to 0, then I can say that it is confirmly a weak interaction. Is it clear?
Yes, ma'am.
Okay. So now coming to the I3 value. So coming to the I3 value here directly. So omega minus has I3 value 0 because it's only one member in that family. And pi minus has I3 value minus 1 because pi plus pi 0, pi minus is there. And omega cascade 0 is half because cascade 0 and cascade minus is there. So only two members is there, so that means I3 is plus of cascade 0. So then in left hand side, what is the value of I3? 0. In the right hand side, what is the value of I3? Minus half. So that means I can conclude that delta I3 is also not 0. That means it obviously a weak interaction, because it is saying that in that first list it is saying that in EM I3 should be conjugate, but in our interaction what I was just discussing, there I3 is not conserved, so that means it should be weak interaction. So the answer will be it is a weak interaction. So I am just only checking S and I3 value. You can check also I value also. In that I value you can see that a delta I should not be 0 because it is a weak interaction, so that means delta I should not be 0 here. So S, I and I3, only these three can help you to find the what type of nature of that nuclear reaction it is. So I think you understand the point that only I have to
Yeah.
calculate S, I and I3. Nothing more I have to check. S, I and I3, these three can give us the confirmation about that nature. And one more thing, we have to at first calculate B, L and Q value, so that we have to confirm that this nuclear interaction is allowed or not. So yeah, then the answer of that first question is it is a weak interaction. Now coming to the second question, I think second question is a very simple question. You can do that. Like I'm giving you a hint that at first check that it is allowed or not. Just check it is allowed or not. Can you tell me it is allowed or not?
I can tell, but I need table.
A table, okay. But see here, for checking it is allowed or not, what I should do say, I have to check B, L and Q
Delta B
value, right?
Q. Yes.
Yes. Okay, so
Yes. Yes.
there is nothing to see in the table because sigma minus sigma plus is a baryon.
Uh,
B means baryon number. Okay, so all the baryons have plus 1 baryon number, all the non-baryonic has the plus 0 baryon number, and all the antibaryon will have minus 1 0 baryon number. So sigma plus is a baryon, so that means it has a baryon plus 1. Pi plus pi 0, these two are not a baryon, these are meson. So that means for these two, baryon number will be 0. That means in the right hand side 0 plus 0 will be there. So is it conjugate here?
Delta Q also 0.
Yeah? What?
Uh, Delta Q also 0.
No, not
Isn't?
delta. Yeah, I am not talking
Uh,
about delta Q. I am just talking about delta B. Delta B is 0 or not here. Delta B equal to 0. See here in that left hand side sigma plus is there only, and in that right hand side pi plus and pi 0 is there. So if I write B for sigma plus is plus 1 and B for pi 0 and pi plus is 0 0. So that means delta B is obviously not equals to 0 because in that left hand side plus 1
oh
is there
yes.
and in right hand side 0 and 0 is there. Okay. So which will give you a 0 value in the right hand side, and in the left hand side plus 1 value is there. So obviously delta B is not equals to 0. Delta B is basically the difference between the right hand side and left hand side. So if I just calculate the delta B, then what it will be? It will be minus 1. 0 minus 1, so that means minus 1. Okay, so that means delta B is not equal to 0 in that equation. So as delta B is not equal to 0, that means baryon number is not conjugate in that equation. So I can confirmly tell that this equation is not allowed because in each and every nuclear reaction B, L and Q should be conjugate. Okay.
Okay. Yes.
I think someone was there. Yeah, maybe, right? So yeah. So do you got the point that is it how it can be not allowed? Because delta B is not equal to 0 here, so that's why I am telling that confirmly this nuclear reaction is not allowed. Just a minute. My laptop has not charged. So then that for the B equation, for the B question, I can tell that okay, this is not allowed. So can you tell me this expression, this D? I am giving you that D as an example, like as an exercise. Pi 0 going to mu plus e minus plus mu e bar. Okay,
This is also not allowed.
this is also not allowed. How? How can you say that?
Yes. I I just taking the charge conservation. LHS is zero and RHS is one.
Charge conservation. Charge is conserved here because in the right hand side plus 1 is there, minus 1 is
Oh,
there, and
yes.
mu
Sorry,
e bar
sorry,
is
sorry, ma'am.
0. Yeah.
Yes, yes. Minus one plus one. Okay, okay. Sorry.
So
Okay, charge is conserved.
so
So now
charge is conserved, but we have to check B and L.
L. Yes.
So for
Actually,
B you
I
can
have
you
no.
see for B these all four are not baryon. Okay, like left hand side is meson and all the right hand side are leptons. So that means the there is no B. That means for all the particles B is 0. So delta B is also 0. So delta, that means baryon number
And
is also conserved. Okay.
but sense of left on in the sense of left on.
In the sense of lepton we have to check is it correct, is it allowed or not. So for leptonic case pi 0 is not a lepton, right? So
So,
pi 0 is
so
0.
it is clear that if yes,
For pi
okay,
for mu
and
plus,
all are left ons.
mu plus is a lepton but it's a anti-lepton. Mu minus is a lepton, so mu plus is a anti-lepton. So that means for mu plus L value will be minus 1. Okay.
And the electron actually is electron is electron, so it is plus one.
Plus 1.
And neutrino,
Mu
anti-neutrino,
anti-neutrino, that
and
means minus 1.
minus one.
So
So actually it is not conserved. Electron number is not conserved.
yes, lepton number is not conjugate because in the right hand side
Delta is minus one.
delta L
Yes.
equals to minus 1. So that means we can say that this D is also not allowed. Okay. Now coming to the E part. E part for E, I think you have heard somewhere that neutrino is a very special particle in elementary particle physics. This particle only interacts through weak interaction. It can't be interact through strong as well as electromagnetic interaction. So if any nuclear reaction which is allowed, you are seeing that in left hand side or in right hand side neutrino is there. Neutrino means it may be neutrino, it may be anti-neutrino, whatever. So if in left hand side or in right hand side, if neutrino is present in that nuclear reaction, we can say that this nuclear reaction will be conformly weak interaction. Even and also it should be allowed at first. Like in that D expression, in that D equation also mu E bar was right in right hand side. So like only seeing this I can say that it is a weak interaction, but obviously it is not allowed at least. So you have to check that it is allowed or not. After checking that, if you can find that in any side LHC left hand side or right hand side neutrino is present or anti-neutrino is present, then we can confirmly say that this nuclear reaction should be weak interaction, because neutrino only interact with the particles via weak interaction. Okay.
Oh yes. Yeah. This is very important line for me actually.
Yeah.
For all actually. But
So
here I'm only.
just a minute, I am just mentioning, I forget to mention here. So if neutrino, that means mu e, mu mu, mu tau, mu e bar, mu bar, mu tau bar, these 6 particles are present in any nuclear reaction in any side, left hand side or right hand side, and also it have to allow. then we can obviously say that it is a weak interaction. Confirmed. We don't need to calculate anything here. Okay, and one more thing is also there. If in any nuclear reaction gamma is there, gamma means photon. So if in any nuclear reaction which is allowed, in any nuclear reaction gamma is present in any direction, left hand side or right hand side, we can obviously say that it is a EM interaction. Confirmly. So these two trick is there. Like as you told that you had a net experience, so that's why I am telling these things, because you have to think that if in any nuclear reaction it's in any side neutrino is present and this interaction is allowed, you can always tell that it is a weak interaction. Just similarly, if photon is there, you can tell that it is a EM interaction. No need to calculate anything. Okay.
Yes, ma'am.
Okay, so these two trick is there, but you have to find at first that it is allowed or not. Otherwise, like if it is not allowed, if the nuclear interaction is not allowed, then no need to, of calculating these things. So at first you can calculate B, L and Q value, which is very simple. So after that, if all the three are conserved, then you can tell that it is a weak or it is a EM interaction. So, but here as I have given you these six interactions, there was no gamma present, so that's why I am not telling that this is a EM interaction. So so that means E is confirmly weak interaction because it's allowed as well as it is like here new bar is present. So
And ma'am,
yes.
question F number question. I can say it is weak interaction, but
How can you say that it is weak interaction? There is no neutrino.
I'm just but electron is anti-neutrino in this sense. Actually, this is not my book, but I am just guessing that.
See,
Actually,
electron is not an antineutrino. New E bar is antineutrino. E bar is electron. E minus means electron.
oh,
It's a lepton.
actually, we can say it is anti-positron.
Yes,
Actually, uh, oh yes, yes.
anti-positron. But I am not talking about positron, anti-positron. We can't say that if a positron is
Yes.
present, then it is a weak interaction. We can't say this, say like that. But if neutrino or antineutrino is there, I am talking about only neutrino, because neutrino is a very special particle in particle physics which only interact with all the particles via weak interaction. So that's why if neutrino is
Yes.
present, then it should be weak interaction. Okay. So
Okay. Okay.
so if AF I am talking, in that AF you can say just calculate L value here, only L. Lambda 0 is not a lepton number. It's not a lepton. Okay, so that means L will be 0. For P is not a lepton, so L is 0. For E minus, L is plus 1. So AF is not allowed because L is not conserved here.
Yes, ma'am.
Okay, so no need to find anything else. No need to find S, I3, anything. We just only calculate that L value. If it is not conserved, then obviously it is not allowed. Okay, so this type of things is there. Just calculate these two also. Now, what was left? That C was left. Okay, you can do later also. I'm just giving you n goes to p plus pi minus. Okay. N goes to p plus pi minus. Just calculate that what type of nature will be here. Okay. So at first calculate is it allowed or not, and after that just calculate what is the nature of that nuclear reaction. So this will be your HW. Okay. So it is your HW homework.
Okay. Okay, ma'am.
Okay.
Actually, I got the screenshot in the
Okay.
all question I have.
Okay. Then it's fine. So just now come to the third question. Yes, this one. This one is a very interesting question. Um, okay, so the question is like the quark system UDS can exist in more than one isospin state. It is a statement. Okay, it is an after question. The question is after that. The question is what is the value of I3 for the quark content UDS? This is the first question. What are the possible values of total I values for UDS states? This is the second question. And can you identify with any known particles? This is the third question. So the first question is like UDS, what is the value of I3? What is the value of I3 of UDS? This is the first question. Second question is what are the possible values of total I values? So that means I have to calculate the I value for UDS. And the third question is example. Do you understand the question?
Yes, ma'am.
Okay. Now come to the answer part. So UDS, at first calculate the I3 value. For the quark model, I think you have heard, or maybe I told you that U and D was like that and S is like that. That means U and D will make a doublet and S will make a singlet. So I3 means like what will be the value of I3 for U, what will be the value of I3 for D, and what is for S. So now U means U has a plus half value because there are two members in that family. So I3 for U is plus half, I3 for D is minus half, and I3 for S is 0 because it's only one member. Okay. Now coming to the I3 part for UDS system. So I3 is a additive quantum number. So only what I have to do, just add these. So that means plus half, minus half, plus 0. So as a whole, what will be the value of I3? I3 will be 0. It's clear?
Yes, ma'am.
Okay. The first question has already done. So that I3 value of UDS is 0 because it's an additive quantum number and we are just going to add all the individual I3 values and the answer will be 0. Now coming to the I value. For I, okay. So for U, the I is plus half. For D, I is also plus half. Because it is a 2 into I plus 1, sorry, which is 2. So I is half for each and every one, and I3 is plus or minus half, but I is half for each and every one. And what will be the value of I for S? For S it will be 0 because only one member is there. So that means for UDS combination, what will be the value of I? I is not a additive quantum number, it is a vector additive quantum number. I am just writing here vector additive, sorry, vector additive quantum number. So what does it mean? Like here, vector additive quantum number it means is like I1, I2, I3. I1 was half, I2 was half, I3 was 0. So that means what will be the value of I? It is like this one minus this one minus this one, that means 0 to 1 in steps of 1, just like a vector addition. So I value will be 0 and 1. So that means the value of I for UDS combination will be 0 and 1 because it's a vector additive quantum number. Okay. So here what was the question? What are the possible values? See here it is written as values, but for I3 it was written that what is the value of I3. So I has two values, 1, 0 and 1, and I3 has only one value, 0. Now coming to the, can you identify with any known particles? So this UDS is there. Uh, to know the example of UDS, you can do two things. At first, you can just remember this list. In that list, you can already automatically see that what is the quark content for UDS particle here. So for UDS, that sigma 0 and lambda 0 is there. So if anyone will say that what is the example of UDS content, then you can already tell that okay, this is the sigma 0 or lambda 0 particle, if you remember. But let's say you don't know, like you totally forget that what is the quark content for each and every particle. Then what you will do? You will just calculate S value for UDS combination. For UDS combination, S value will be -1 because D is also 0, U is also 0. Only AC has there, so that means -1 will be there, S value. And you can do one thing, I3 value. I3 value I have already calculated. For UDS combination, I3 is 0. So that means one particle will be like that, which one has I3 is 0 and S is -1. And it should be a baryon because UDS, that means QQQ combination is there. So just remember a little bit, and after that you can say that it may be sigma 0 or lambda 0. Or one thing also you can do, if I equals to 0 or 1, so if I equals to 0 means only one member will be there, and obviously in lambda 0 only one member is there. And if I equals to 1, that means 3 member will be there, and obviously for sigma 0, sigma plus, sigma 0 and sigma minus 3 member were there. So lambda equals to 1 corresponding to, I equals to 1 corresponding to sigma 0, I equals to 0 corresponding to lambda 0. Is there any problem?
No, no, ma'am.
So if you can, so anyone, just if anyone ask you any quark content and they were just asking that what type of particle it is, you just calculate S value of that, I3 value and I value, so that you can find what will be the particle content, like what will be the particle corresponding to that quark constituents. Okay, so this third question has also done. Where was that? No, not this one. This question. This question has already done. The first answer is 0, second answer is 0 and 1, and the third answer is lambda 0 and sigma 0. Now coming to the fourth question, I think time is over, so we will talk about fourth question in next class. But you can also check in your home. Can you do that? Like if it will be done by yourself, then it will be very good. Like here the question is, you have to find the missing particle. This missing particle or this missing particle.
Okay, yeah.
So you have to find that missing
That
particle.
I will do, ma'am.
Just similar thing. At first what you will do, B, L, Q, S, I3. These 6 things are very important. Nothing more than that we need. So these 6, if I calculate, then I can obviously calculate what will be the value of that missing particle. And also for missing particle, one more thing is there, Q, that means quark content. So these 3. So for that you just remember a little bit about these tables. Where is the table? Yeah. This table, quark content table, and this table is not that much important, you all know that. And this table is little bit important. So only this table you have to remember, and this quark content table you have to remember. Then you can find what will be the value of all the questions. I think 90% questions is like that what is the missing particle, what will be the nature of that interaction, that type of thing. In net also, if you are going through that net questions also, you can find that type of questions. So if you just remember these two list, then you can find all the answers.
Yes, ma'am. One question is mandatory in all in this in some example.
Hello.
Hello.
Yeah.
Yes, ma'am. My voice is clear, ma'am.
Yes.
Actually, this type of question is mandatory in NET exam.
Yes, that's why. Yes.
Uh,
Have you gone through that type of questions in this net?
yes.
This net, like you just appeared on that net, right? That July, no, October, October, no, sorry, September net.
Yes, 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 ma'am.
So in that September net
Yes.
also that type of question
It's
was
in
there.
September. Yes.
Like maybe some what type of question was there? Like what is the nature of that interaction,
Uh,
or some missing particle, or what?
no, just to check the conservation,
Huh? Sorry,
reaction.
I can't hear you. Sorry.
Actually, giving some. Hello.
Yeah. Tell me.
Hello, ma'am. It's about conservation. What I actually some checks question and the
Okay, conservation was there.
conservation. It is conserved or not.
Okay, is it concept or not? So like that. Like if I just calculate this type of questions, then you can find all the questions. You can answer all the questions in your net also. Like for that quark content, these type of questions are common and it's a very simple. If you just clearly calculate all the A's, I and I3 value, you can obviously do all the questions. Okay, this is not that much problematic.
Okay, ma'am. Ma'am.
So in the next class, I will do some more questions about that because I have some more questions. That question number 4, question number 5. I have some more questions on quark model, but I am doing a little bit reverse way. Like you have seen some of the questions you have seen in any book that at first they are saying they are asking for a very easy question, and after that some difficult question, then some difficult question. That type of question was there in any book, in any textbook, or in anywhere. But I am doing totally reverse process. Whatever you have done in that first 3 questions, these are the most difficult question for quark model, and after that I will do the most simple questions. Okay, so then it will be very good
Yes,
feeling
ma'am.
for you. Like at first if you do all the difficult
Yes.
thing, then after that the simple thing will be very easy for you. Like only fraction of second or 30 second will be taken for answering that questions. So I am doing that reverse process. At first 3 or 4 questions will be very difficult, and after that all the questions will be very simple. So hope you will
Yes,
enjoy
ma'am.
this. Okay.
Yes, yes. Very, very, very enjoying this.
Okay. Okay. Bye bye. It's time over. Bye bye. See you in
Okay.
next class.
Yes,
And one thing is that in
yes,
the
ma'am.
next class, have you gone through one notice that in the next class will be on Saturday, not in Sunday. Maybe someone from
No,
NPTEL coordinator, it was mentioned. It was not mentioned.
no.
Okay.
Get
If,
ma'am.
okay, if it is not mentioned, then I am telling you that next class will be on Saturday, not on Sunday, and it will be from 5 to 6 p.m. Same time will be there, but it will be on Saturday. Okay.
Only next week.
Only
It
next
is
week.
for 2 weeks.
Only next
Last
week.
2 weeks.
No, only next
Oh,
week.
okay.
Last week will be on Sunday also, because I will be
Ma'am.
out of
Yes.
station.
Okay, okay, ma'am. Ma'am, it can possible after completing the week, then will be going on continuously before the exam.
Uh, basically I am a member of NPTL. So member of NPTL, what they will do, they will just take a class only 12 weeks, and basically our task was you have to discuss about previous year questions. But as Archana is doing the same thing, that's why I am giving you the different thing. And also the rule is like that I have to complete only 12 classes. uh, but if you need, then you can just contact me personally, I can help you. Okay, like not like that you
Uh,
have to give, I have to give that type of classes each and every Sunday. Only for 12
no, no,
classes
no.
I
Yes.
have to do. But after that, mm, if you want any help, then you can message me or you can text me, I can answer. Okay.
How I text you, ma'am? Actually, uh, I know I have no any email.
Huh?
How how I text you, ma'am? Uh,
Yeah, okay, okay. I will give you, no
uh,
problem. I will give you. But I am talking that I can't
uh,
do that type of question and answer session each and every Sunday. Only up to 12 a week I can do, and after that, if you have any doubt, you can text me or you can message me in my email ID, WhatsApp number, whatever. I will give you, but I am telling that it is not possible that each and every Sunday I am taking a class like that. Okay.
oh, okay, okay, ma'am. Just actually, we have only 2 week to revise the all nuclear and particle physics for MSc level.
Yes,
So
yes. Yeah, I understand that. But see, in the next class, I will do about some more question on quark model, and after that, in the last class, if you want something more from me, then you can tell me. Uh,
yes.
like some, maybe some question answer for from all the nuclear and particle physics, it should be better, maybe like whatever the syllabus was there, if I prepare some questions on that whole syllabus, and we will discuss about that, then it will be good. Like, I don't know what will be the question in the exam, obviously I don't know. So I will do
Yes.
some questions, I will prepare some questions for you for that, totally based on that total syllabus, like not only quad model. At first the cell model was there, nuclear model, then detector was there, then I think that QED QED part was not there, QCD is there, QCD quark model and all these things. So if you will tell, then I can prepare all some questions about all the things, so that it will be discussed in last class. Okay.
Okay, ma'am.
Is it fine? Like, is it reasonable?
Yes, yes. It's okay. It's
Okay.
fine.
Okay, then you can revise all the things very clearly, and after that you can prepare for your exam. And okay, I'm pasting you here in that message. I'm giving my WhatsApp number. If you have any doubt, you can just contact me. And this is my email ID. This one. This one is email ID. Okay.
Thank you very much, ma'am, for this, ma'am.
Okay, just remind me something. Like, if you have any doubt, you can just ask me. And we will
Yes.
see in next class, which will be Saturday, not in Sunday, because
Yes.
I will be not there.
I yes. I will need to remember on my phone.
Yeah, otherwise you will forget. Like, I think they will inform you before the class. I don't know when they will inform, but I am telling you now.
Uh, Actually, it may be an announcement. I will check.
Yeah, like it may be something, I don't know. They said that they will inform all the students, but if they did not mention it yet now, they may inform later also. So don't know. Okay, bye bye.
Yes. Yes. Okay, ma'am.